In this lesson, we are going to look at something called literal equations. And all we're going to do is just to look at a few examples. So what literal equations are basically about is it's actually a very practical aspect of mathematics because we use it a lot in physical science, where we have a formula and we have to solve for the unknown. So in this case, we just have a equation that says qx equals to mx plus b, and it says we have to make x the subject of the formula. Now all of these q, m, p, they just represent numbers. So if we had a normal like linear equation where we had like maybe 2x equals to 3x plus 4, then what would we do to solve for x is we'd start by taking all your variable or all your terms that contain x to the left hand side. So if we start with that, so we have qx minus mx, because we take it over, change the sign, equals to p. Now in this case we can't add these two, but what we can do to extract x or to get x on its own is to actually factorize x out of these two terms. So if I factor out x, I will be left with q minus m equals to p. And then to get x on its own, because x is now multiplied with this bracket over here, to get rid of the bracket, I simply divide it on both sides. Then this will cancel, and you will be left with x equals to p over q minus m. So this is now x is the subject of the formula. And now in cases where you have scientific values, you can substitute in your values and you can find the value of x. Right, now here it says make r the subject of the formula, and over here r is quite on the inside of this formula. And what we do in this case is we're going to start by working our way from the outside in. So the one that's most loose, if you want to think about it like that, is this pi over here, because I can easily get rid of pi by just dividing both sides by pi. And then on the one side it cancels. So what I'm left with now is going to be a over pi equal to r squared minus small r squared. Right, now what's next to get rid of is this term over here, because we can just, because this term is added on this side, we can just take it over to the other side and then make and then subtract it. So this is then a over pi minus r squared equals to negative small r squared. Okay, now in this case you've got a few options, and mostly in these sums there's sometimes numerous ways to do them, but for me personally I like to get the one I'm solving on the left hand side. So we can actually in this step maybe take this term and take it over that way, and then just take these terms and bring them here. This will then do for two purposes basically. This sign will then become a plus, so we'll get rid of the negative, and then also because we want our subject of the formula on the left hand side. So this is then r squared equals to, now when I take these two over, it's going to become plus r squared minus a over pi. Okay, final step, we need to get rid of this guy. And to get rid of a square, you take the square root basically, and what you do on the one side you have to do on the other side. So these guys cancel, then you're left with r equal to the square root of r squared minus a over pi. Right, then the final example. Now once again go back to where we solved linear equations, and these guys contain fractions. So how do we get rid of fractions very easily is to first identify what your lowest common denominator is. So that's just ab, and then we simply multiply each term with your lowest common denominator, and then we cancel. This a and this a cancels, this b and this b cancels. So what we have left is bx plus ax equals to ab. All right, now as in the first example, what we want to do is to factorize out the x to get it on its own. So we are left with b plus a is equal to ab, and then we get rid of this bracket by dividing it on both sides. So if I divide b plus a and here b plus a, then I've got x, these guys cancel, x equal to ab over, I'm just going to write it as a plus b. So that was it for the examples, and then we are done.